Hi, today we will learn how to solve derivatives of transcendental functions. First of all, let's take a look at these derivatives. The derivative of sine of x is cosine of x. The derivative of cosine of x is minus sine of x. The derivative of cotangent of x is minus square cosecant of x. The derivative of tangent of x is squared secant of x. The derivative of secant of x is secant of x times tangent of x. And the derivative of cosecant of x is minus cosecant of x times cotangent of x. Let's solve an example. Sine of 8x. First of all, we place the derivative of 8x, then the derivative of sine, which is cosine, evaluated in 8x. If you can notice, this is the chain rule, but I placed first the derivative of the inside. Another example. Cosine of 3x squared. First, the derivative of 3x squared times the derivative of cosine evaluated in 3x squared. But as the derivative of cosine is minus sine, our derivative is negative. Another example. Secant of x over cosecant of x. We use the quotient rule. G times derivative of f minus f times derivative of g over g squared. We simplify, and we simplify again to obtain this. Other things you need to know are that the derivative of a natural logarithm, or ln, of x is the derivative of x over x, and the derivative of e to the x is the derivative of x times e to the x. For example, natural logarithm of 3x plus 2, we place the derivative of x over x. Another example, e raised to the square x, it's e raised to square x times the derivative of square x, which gives us this result. The last example, e to the x over x minus 1. You know, quotient rule. So g times the derivative of f, in which we use the chain rule, minus f times the derivative of g over g squared. We simplify, and some values get cancelled, so we get something like this. Thanks for watching.